At midnight, the moon vanishes. 1.3 seconds later, its light and change in gravity reach Earth. The ocean does not fly away. Earth does not fall into the sun, but the planet has quietly lost a machine it used for billions of years, and nothing on the surface knows why yet. The first surprise is how normal the ground feels. Gravity barely changes, and the day keeps going. The real damage begins in systems that use the moon as a pull, a lamp, and a clock. Forget the movie explosion. This disaster is quieter. First the sky changes, then the coasts. Living things lose a calendar. Much later, even the angle of Earth may wander. Start with the first night, because it is almost suspiciously calm. If the moon was full, a bright landscape would drop into darkness. Stars would look stronger, shadows would vanish, and anyone outside would stare at the hole where the most familiar object in the night sky used to be. Earth and the moon orbit a shared center of mass buried about 3/4 of the way to Earth's surface. Remove the moon, and Earth keeps its small sideways velocity. Its path around the sun changes only slightly. Earth keeps rotating. The sun rises on schedule. Seasons continue, and your bathroom scale stays boring. Losing the moon is more like deleting an important contact than dropping the entire phone. Power grids, phones, cars, and most satellites keep working. Astronomers, sailors, and coastal engineers notice instantly. For everyone else, the first clue may simply be that the night feels wrong. The sun outweighs the moon enormously and already controls Earth's yearly orbit. The moon fine-tunes our motion. It is not the rope keeping us from falling into the sun. Cross off that apocalypse? By sunrise, civilization is standing. That calm is the trap. At the shoreline, trillions of tons of water have just lost their main conductor. Next, the oceans must relearn their rhythm. The moon does not pull every part of Earth equally. The near side feels a stronger tug, and the far side a weaker one. That difference stretches the oceans and helps create repeating high and low tides. Tides would not disappear. The sun also raises them, even from far away, with roughly half the moon's tide-generating force. Solar tides remain, so the new rhythm is smaller but not flat. Would every coast face a giant wall of water? No. Tides are moving waves shaped by ocean depth, continents, wind, and rotation. Remove the lunar forcing, and existing currents continue while the pattern reorganizes. Local surges are possible, but there is no universal wave. Over several tidal cycles, water levels stop matching familiar tables. Places with large lunar tides see major reductions. Geography protects others. There is no single worldwide result because every coastline edits the wave differently. Harbors built around high tides become harder to enter, and mudflats stay exposed longer. Fishing, ferries, floodgates, and drainage need new tables. The ocean has simply stopped reading our old timetable. Tides push saltwater into estuaries, stir nutrients, carry larvae, and flush bays. Weaker tides change that mixing. Water can stagnate and sediment settles elsewhere, an ecological plumbing problem across entire coasts. The intertidal zone is a world between high and low water. Barnacles, crabs, shellfish, birds, and algae divided into neighborhoods. Shrink the tidal range, and those neighborhoods move or disappear. Tidal turbines lose power, and ecosystems face a new beat. The ocean has not lost the whole band. It has lost its loudest drummer. Millions of living things were dancing to it. Now the planet's night shift loses both light and schedule. A full moon can make the ground hundreds of times brighter than a moonless sky. Predators use that light to hunt, prey, judge danger, and many animals change when they travel or feed. Some hunters lose visibility and some prey become bolder. But food webs are chains, not scoreboards. Change one hunting window and effects reach insects, plants, and competitors. Nature's night shift lost the group chat. For many marine species, the moon is also a monthly clock. Animals time migration, feeding, hatching, or spawning, so currents, darkness, and neighbors line up on the same night. Corals are the spectacular example. Temperature and season prepare them. Lunar cues narrow the date. Colonies release eggs and sperm together because those cells last briefly, and the adults cannot exactly swim over for a date. On a healthy reef, synchronized spawning looks like an underwater snowstorm. Corals' inherited clocks do not instantly vanish, but the external cue does, so timing can drift between colonies and generations. Some species adapt to sunlight, temperature, or internal cycles. Others reproduce less successfully before evolution catches up. Species with narrow breeding windows are especially vulnerable. The danger is countless small schedules no longer matching the world around them. Over generations, natural selection favors creatures using another signal. Survivors rewrite the calendar. But while life adapts, the planet faces a slower question. Who keeps Earth's tilt steady now? This is the moon's slowest and most debated job. Earth spins with its axis tilted about 23 degrees, creating seasons. The axis also traces a slow circle called precession. The sun, moon, and other planets influence how that direction changes. The moon makes Earth's axis precess faster. That speed keeps it away from some resonances with other planets. In plain English, the moon stops several slow wobbles from repeatedly pushing the same way. With the moon, Earth's tilt stays roughly between 22 and 24.5 degrees over long cycles. Climate still changes, but seasonal geometry stays familiar. Moonless models generally produce larger variations. You may have heard that moonless Earth flips between 0 and 85 degrees. That is a possible chaotic range, not a schedule. Other simulations find a smaller band for hundreds of millions of years. The future depends on planetary interactions. Removing the moon simply opens more possible paths. A larger tilt means stronger seasons, brighter high-latitude summers, and darker winters. At very high tilt, the poles can receive more yearly sunlight than the equator. Earth will not cartwheel before breakfast, but its climate map gets strange. Rainbelts, ice sheets, deserts, currents, and growing seasons respond to where sunlight lands. Changing tilt moves climate zones, sometimes slowly enough for migration, and sometimes faster than forests can follow. These are not next week changes. They take thousands to millions of years. Civilization has warning, but ecosystems repeatedly face new seasonal limits. The danger is not one storm. It is the rules changing again and again. Even this does not guarantee a dead planet. Studies suggest moonless Earth could remain habitable for long periods despite wider tilt changes. The honest answer is less predictable stability, not instant climate chaos. Habitable does not mean familiar or easy. Now let the moonless planet run forward. The day stays 24 hours. Removing an external pull gives Earth no instant spin boost. Clocks, jet lag, and Monday mornings remain normal. What changes is the tiny break that has lengthened days for billions of years. Lunar tidal friction currently adds roughly a couple of milliseconds to the day per century. Solar tides and other effects still alter rotation, but the main break is gone. Future days stay shorter than they otherwise would. Solar and lunar eclipses disappear. No lunar disk covers the sun, no shadow crosses Earth, and no red moon enters Earth's shadow. One of nature's best coincidences ends with the moon. Astronomers gain a consolation prize. Every clear night becomes moonless, making faint stars, galaxies, and comets easier to see. The sky becomes richer because its most familiar object is missing. Humans survive. Ports are redesigned, forecasts rewritten, and ecosystems protected where possible. Lighting replaces visibility, though not gravity. The engineering problem is large and expensive, but it does not erase civilization. Life continues. Some species decline, others spread, and new relationships form. Evolution has handled changing oceans before. The painful part is speed. Sudden loss gives ecosystems no preparation, even on a livable planet. So Earth survives the first night, and humans probably survive the future. But oceans grow quieter, coasts reorganize, biological clocks lose their cue, eclipses end, and Earth's long-term tilt becomes less predictable. The moon's absence is survivable, but never truly local. The moon is not decoration. It is part of Earth's machinery, pulling water, breaking rotation, guiding life, and helping steady our spin. You notice that hidden machine only after removing it. Tonight, look at the moon and remember, that quiet circle moves oceans and keeps time. Subscribe and like for more questions that redraw the world, one doodle at a time.